video of this new unit, I'm going to introduce some of the root stuff that we're going to do, the three skills that you can see here. So we're just going to briefly recap what a root is, just in case any of you have forgotten from back in the first unit this year, which we did indices. And then we're going to look at three new skills, how to simplify, multiply, and divide. As always, pay attention as much as you can through the video, but if at any point you're happy, you can stop the video and have a go at the activities. So let's jump straight in. What is a square root? So hopefully you've seen, if you type in the calculator, we can look at things like square root of 9 is 3, square root of 16 is 4, and square root of 25 is 5. What does that mean in the real world? Well, I've drawn myself a little diagram. If we think about this square here, it's made of 9 smaller squares, so like 1, 2, 3, 4, 5, 6, 7, 8, 9. If you were to measure the sides of that square, we can see it's 3 by 3. So what that means is, if we do the square root of 9, i.e. how long are the sides, they are 3 long. Similarly here, how long are the sides of a square with 16 squares, they're 4. 25 squares is 5 by 5, and so on, because 5 times 5 is 25. So a square root literally refers to a square, and it's how long the sides would be if the area was that number. These numbers, because they're what we call perfect squares, is where the side lengths are exact, so like 3, 4, and 5 is not like 4.2 or 7.8. We can get square roots where it does give us a weird number. So like, for example, if I tried to do something like this, okay, which doesn't exactly fit on the boxes, you can see it's like 6 and a bit, it's about 7. So if I was to say the square root of 7, well, that's not a perfect square because the side lengths are not whole numbers. It's not a perfect square because it's kind of like, if you look at this length here, it's like 2 and a bit, so it doesn't work. So perfect squares are the ones which are whole numbers. Okay, so that's what a root is. It's the side lengths of a square with a certain area. And now we're going to jump into how we can look at this. And we're going to do some simple multiplication first. So, surds. If you hear this word surds, you'll sometimes hear it used interchangeably with roots. And surds is when we kind of use roots in different calculations or multiplications, division, etc. So anytime you see the word surd, just think roots. Okay? So I put a couple of facts on there that hopefully in grade 8 we already know. 4 9s make 36, and from our algebra units we know that x times y would equal xy. So let's see if we can apply some of the same logic to square roots. Let's start off with 4 times 9. So if you think about 4 times 9, we know that's a fact. We also know from our algebra units that if we do the same thing to all 3 parts of a question, then that means that it still works as a balanced equation. So you can see in green there that I've done a square root of all 3 parts. Now square root of 4, if you draw a square with 4 squares, it's going to be 2 by 2, 9 is 3 by 3, and 36 would be 6 times 6. So the square root of 4 is 2. The square root of 9 is 3, because 3 times 3 is 9. And the square root of 36 is 6. So with this particular example, we can say, well, 2 times 3 is 6, which means that if we square root them all, it's fine. And if we square them all, we get 4 9s make 36. What about for the algebra example? We can now see that if we square root everything, as long as we do it to all the parts, it's the same. We can do the same logic to the 2 algebra parts. So it means if I take any 2 square roots and I multiply them together, the answer is the square root of the 2 numbers times together. Let's look at another example of that. Okay, or some more examples. Here, 3 times 7 is 21, which means that the square root of 3 times the square root of 7 is also the square root of 21. If we do 2 numbers the same, so like 2 5s together, we can actually see that 2 are the same means we can cancel out the square roots. We can do it algebraically, like a times b gives you ab. And remember with algebra, we don't need to write the multiplication sign. And the final one we can look at here, if we have two things next to each other without any symbol, we can assume they're multiplied and combine the letters. We can also do a similar thing here, where we have a number and a letter. Square root of 10 times the square root of y is 10y. The key takeaway is this here. It's the same as in multiplying any other numbers, like 3 times 7 is 21, so the square root of 3 times the square root of 7 is 21. You just times the two numbers together and put the root sign above it. Easy as that. There's no hidden catches, that's just the way you do it. So how can we start to use this with our square roots? Well, this leads neatly into the next thing, which is called simplifying. Let's imagine you get a question that says, simplify the square root of 27. First thing you need to think about is the factors of 27. 27 can be made in different ways. We can say 27 is 1 times 27. Anything has 1 as a factor, even prime numbers. We can also say that 3 and 9 make 27. So what that means is we can rewrite the square root as the product of two other square roots. So instead of writing just 27, we can split it up into 1 and 27. But even better than that, we can say let's split the 27 into a 3 and a 9. If you couldn't think of the numbers to split it up into, then you can draw yourself a factor tree. That's the one that looks something like this, where you start with 27, you split it up into two numbers, say what two numbers can I multiply 27? I can do 3 times 9. 3 is a prime number, so you circle it because it's prime. Then 9, you can split up into a 3 and a 3, and both of those are prime. So 27 is 3 times 3 times 3. They are all primes. So hopefully you remember doing this. This is a prime factor tree, and that's going to be useful to us later on in this unit. So just to give you a little sneak preview, a prime factor tree is sometimes useful, and we'll come back to that at a later time. So the important thing here is we can split up 27, or any number, into factor pairs. For example, 3 and 9, and 9 is going to be very important. That's a very important number, and hopefully some of you will remember why from earlier on. If you can't, let's go back and let's look at 9. We said that the square root of 9 is 3. It's a whole number. So what that means is that when we come to this example, we can say, well, the square root of 9 is actually a whole number. We can write that as 3. So what does that mean? Well, if the square root of 9 is 3, then we can replace the 9 with a 3. So this 3 here has come from this here. So once we know that we can replace that, we can write it as what we call a simplified surd, where we've got 3 lots of root 3. So instead of writing it as a big root, we have a small root. We just have root 3, which is a very small number, and we have a whole number, and we can multiply, and this is called simplifying a surd. So what does that look like when we do it from start to finish? Well, I've just left this one in here so you can see what it looks like from the one we did before. Let's try root 48. So the first thing you do is you think of your factor pairs. So the obvious one is 1 times 48. You could also do 2 times 24. And we can keep going. We can do 3 16s, we can do 4 12s, we can do 6 8s. So there's 5 different ways that we can make 48. But we're not going to use all of them. We're looking for particular numbers. So now we know we've got those factor pairs, we can rewrite the root, which is this bit here, as a product. Instead of 1 times 48, you can do it with the square roots and so on and so on. But we're looking for particular numbers, and hopefully you've been paying attention to the previous part of this video. 2 numbers should jump out the page at you. The 2 numbers are root 16 and root 4. These, if you remember from earlier, are our perfect squares. What that means is if you type them into a calculator, it gives you a whole number. The root of 16 is actually 4, because 4 times 4 is 16. So we can write 4. The root of 4 is 2, because 2 times 2 equals 4. And 4 times 4 equals 16. So these two are going to be very useful to us when we're simplifying. What that means is because we know these two are special, you can see that we can say the 16 can be replaced with a 4, the 4 can be replaced with a 2, and that gives us two different ways which we can simplify. We can say that you've got 4 root 3's or 2 root 12's. So how do you choose the right answer? Well, it's really easy. Okay, you just choose the biggest square. If you ever, this won't happen very often, but if you ever get one of these situations, choose the largest integer, the largest whole number. Square numbers are something we call irrational, i.e. you cannot find a value for them. The decimal goes on and on and on forever. So what we don't want is that to be a very big part of our question. We want it to be as small as possible. Integers are rational. They make sense. They have an end. So we want to make that number the biggest part we can. Here we can see that 4 is way bigger than 2, it's doubled size, so we choose the 4 root 3. So we don't use this one, we use the 4 root 3. So let's just summarize that. Like with another example, take root 96. I would say if you haven't got a list, maybe copy and paste one from Google. You can just Google square numbers, it will give you hundreds of them, and you can maybe keep a list of those for your work today. You think about 96, you go through and think, okay, 1 is a factor, 4 is a factor, 16 is a factor, and none of the others are, which means you know that you're going to use 16, because it's the largest square factor. Once you know that, that one goes in here. And you know that 16 times 6 is 96. You can always use your calculator to help you with that. So the 16 goes there. We know it's root 6. And then you take this 16 and you say, well, I know root 16 is 4 times 4. So you replace the 16 with a 4. And the other bit just stays the same. And that's it. So choose a square number and simplify it. Final thing to add here is obviously you've got this list of square numbers. If you get a number, I'll just give you a quick example. Let's say you had a root of 47. Well, none of those square numbers are factors, so you can't simplify it. So you just leave it as it is. So some of them can't simplify. All the ones I'm going to give you today can, but sometimes you'll get numbers that can't simplify because they don't divide by any of these numbers. Okay. Final thing for today, how to divide. Well, we've done multiplying, and we said multiplying surds, or roots, is the same as multiplying any other number. Dividing is also the same. Let's say we took two numbers. Let's say we divided the square root of 16 by the square root of 4. Okay, one way we could do it is we could look at the numbers. We know that 16 is 4 times 4. Hopefully, you'll see that there's the same numbers coming up over and over again. Particularly square root of 4, you're going to see that lots. Square root of 4, 2 times 2 is 4. So 16 becomes 4, 4 becomes 2, and we know that 4 divided by 2 is 2. So one thing we could say is if we do this, square root of 16 divided by the square root of 4 is going to give you 2. But not all the numbers are going to simplify, so let's look at a more general rule. Ooh, too quick. We could also say this part here. Instead of doing each one individually, we can just say square root of 16 divided by the square root of 4. We'll just forget the square roots for a second. Just do 16 divided by 4. 16 divided by 4 is 4, and the square root of 4 is 2, and as you can see, you get the same answer. So, to summarize, and I've used a little rule here, when you're multiplying two surds, you just take the two numbers, so like A and B, and you times them together. So like 2 and 7, 2 times 7. When you're dividing, you just take the top one, divide it by the bottom one. If there's more than one, you do the whole thing. Top divided by the bottom, so like let's say I had 42 and 7, you do 42 divided by 7, which is the square root of 6. And then when you're simplifying, that means you look for a perfect square that you can divide that number by. So 9 times 7 is 63, 9 makes 3, so it's 3 root 7. And choosing your perfect square, like I said, if you don't know them off by heart, get a list off the internet, 1, 4, 9, 16, 25, and so on. Because remember, 4 is a square number because it's 2 times 2, 3 times 3, 4 times 4, 5 times 5, 1 times 1, 6 times 6, and so on, forever and ever. And that's the 3 rules that you're going to need to start with today. We're starting with surds today because we're going to use them in all of our geometry problems for this unit. This unit is predominantly geometry, but we need to know the surds before we can learn the geometry parts, because all of the geometry we're going to do involves working with these surds. So multiplying, dividing, and simplifying. If we can't do those, we can't do the rest of the unit. So that's why we focus on them first. Just one, as like I said, so you can go back on this video, regroup. Just remember, multiplying times the 2 together, dividing, divide the 2 numbers. Obviously, if there's more than 2 numbers, you still treat them as normal numbers, just put the root on the top. And simplify means find a square number, like one of these, and write it as a whole number. So you end up with a whole number and a square root. And that's it. So, as always, I'll be on the Google Meet. If you need any more help, please re-watch this video if you want to go through anything again. And if you're happy with this, please try the 2-part practice. The first part is just doing some simplifying, and the second part does some multiplying and dividing. After you've multiplied and divided, you will also have to simplify. So your answer should always look something like this. Or, if it doesn't simplify, like 47, looks something like this. So all your answers will be either a whole number and a square root, or just a square root. Enjoy.